Summary of Class 9 Semester 2. Chapter 9, The Land and the Continuity of Life. The world consists of approximately 30% land and 70% sea. Although there is less land than the ocean, land plays an important role in life on Earth. Land consists of layers. Each layer is composed of different components. The outermost layer that is closest to humans is the soil. Then, what are the components of the soil? Are only humans living above ground? Come on, study the summary of the material below to find out the answer. A. The role of land. Soil is an important component in survival on Earth. For example, plants need nutrients or nutrients in the soil in the form of minerals and water. Legumes need bacteria in the soil to help roots absorb and process nutrients. The role of soil for living things, namely, a place to live for animals and bacteria. Providers of human health needs and support, water supply and filter. Animals and bacteria live. Soil serves as a place to live for various kinds of land animals and microorganisms or soil bacteria. Provision of human health needs and support. Various human activities are carried out on the ground. Most human homes are built on the ground. Humans use various types of soil as building materials for houses. Many handicrafts and household items are made of earth. Plants that are the main source of food for many living things grow in the soil. Contains essential nutrients for plants. Store a lot of metals. Coal and petroleum that humans need in their daily lives. Gold, silver, tin and other metals are widely distributed in the soil, but only a few areas of Indonesia contain these metals. Coal and oil are stored in the ground, so mining and drilling are necessary to obtain them. Water providers and filters. Water sources are in the ground, but many are above ground, such as lakes, rivers and the sea. To get groundwater, you have to dig up to several meters of soil to make a well. Groundwater is widely used by animals, plants, and humans. Clean water that comes from the ground is used for drinking, bathing, washing, and cooking by humans. Households and industries produce waste in the form of water. Some of the wastewater is treated and some is directly discharged to the ground. Pollutants that enter the soil through water or directly enter can be neutralized and become materials that do not harm the environment. Because in the soil there are bacteria or microorganisms that function to decompose complex compounds or harmful compounds into simpler ones and do not damage the environment. B. The role of soil organisms. Soil organisms are in the upper soil layer, approximately 10 centimeters below the soil surface. Biological activity in soil, 80 to 100% is carried out by fungi and bacteria. The results of biological activities carried out by animals, fungi, and microorganisms can affect fertility, soil texture, and soil friability. The following are examples of soil organisms, namely earthworms. Decomposers. Soil organisms decompose organic materials derived from the remains of living things. For example, leaves that fall to the ground, branches and the bodies of dead animals into simpler organic matter. Help weathering aids into inorganic materials are soil minerals. Organic matter and minerals in the soil are called nutrients or nutrients for plants. The existence of soil organisms as decomposers is used to make compost, namely fertilizers from organic materials. Chemical reagents in the soil, bacteria in helping the decomposition reaction of organic matter. For example, the bacteria Nitrosomonas, which helps the decomposition reaction of complex organic matter derived from the remains of living things into nitrate, a compound needed by plants. Mycorrhizae are fungi that help the absorption of nutrients in the form of phosphorus in plants. Decomposers of pollutants in soil. Soil organisms act as biological agents that are able to clean up pollutants in the soil. Soil organisms break down chemicals that enter the soil, such as herbicides from agricultural products. Herbicide decomposition is carried out more quickly if the activity of soil organisms is high. Toxins and pollutants such as arsenic, chromium, and mercury can be locked up in the soil as they accumulate in the body of bacteria. These pollutants do not cause pollution to get worse. Soil disease prevention under normal conditions. When the soil has high organic compounds and the activity of organisms, the soil organisms can fight disease organisms that enter the soil. Normal soil conditions are created when agricultural and plantation activities are not excessive and do not use many chemicals for fertilizers and pesticides. Naturally, soil organisms utilize the principle of biological control, namely predators and prey, so that organisms that disturb the soil can be controlled. Affecting soil texture. Based on its texture, soil can be classified into several types. Soil type is determined based on the number of constituent particles that are most abundant in the soil. The particles found in the soil are sand, clay and silt. The following is the classification of soil texture based on particle size. Soil texture is the size of the particles that make up the soil, is a measure of the relative proportions that make up the soil. Soil has different particle sizes, so it can be classified into clay, sand, and a mixture of the three soils. Soil types are named based on the principal particle size or the most abundant combination of particle sizes. For example, sandy clay can be made into a thin, long, gritty band so that we can tell that the soil is composed of clay and sand. The formation of soil texture is assisted by organisms such as worms or plant roots that can accelerate the breakdown of these particles from rock. Plant roots are able to penetrate rocks because they secrete acids that can chemically petrify rock weathering. Soil is divided into several types based on its texture, which also affects its properties. Sand soil has a grainy texture, so it has high porosity, is less able to store or hold water because water easily flows through large enough gaps. Clay is composed of very small particles so that the clay can retain water longer. This can be seen from the movement or slow flow of water when the clay is given water. The nature of the soil affects its ability to provide the nutrients and water needed by the plants on it. Fertile soil has an almost equal mix of clay, and sand. Its nature is very beneficial for plants on it because clay is difficult to penetrate, so the water content of the soil can be maintained. The presence of sand is beneficial because it will have pores large enough to make it easier for root cells to get oxygen. The difference between clay and clay is that clay is a flexible soil, difficult to penetrate water, lighter in color than clay, not much mixture of sand and small rocks, used as the main ingredient of pottery and ceramic products. Clay soil is soil consisting of a mixture of sand, clay, and silt in almost equal amounts. Regulating looseness and soil structure. Soil structure is the arrangement of soil particles into a lump. Soil particles are held together by adhesives like organic matter produced by soil organisms. The mucus produced by soil organisms mixes with the soil, making soil particles collect to form lumps of soil. A good lump of soil supports the life and growth of soil organisms. Fungi in the soil also aid in the formation of lumps of soil. Soil structure and friability are interrelated. Soil organisms are able to create soil pores that can loosen the soil and allow air to enter the soil, aeration. Soil pores are formed due to the movement of soil organisms such as earthworms, centipedes, and millipedes. Soil pores are useful for increasing the absorption of water by the soil. Soil that has aeration and sufficient amount of water is very good for supporting plant growth. C. Soil formation process. Soil is a mixture of weathered rock, decomposition of organic matter, minerals, water, and air. Soil is formed due to physical, chemical, and biological weathering. Physical factors that affect weathering are climate, sunlight, rainfall, which affects the temperature of the earth so that it accelerates weathering of rocks. Biological weathering, assisted by soil and plant microorganisms. Other factors that influence soil formation are rock type, topography, or soil relief of an area. To form soil several centimeters thick, it takes thousands of years. When the soil is dug deep, it usually shows layers of soil horizon, that have different color gradations. The following are the layers of the soil. At the top, plants obtain nutrients in the form of water and minerals from the soil, but vulnerable to loss of mineral and nutritional content due to natural events such as rain, flooding, landslides, and erosion if no plants live on it. Erosion is the movement of part of the soil layer is a natural disaster caused by humans. Occurs due to the rapid flow of water that passes through the land area and erodes the top layer of soil that is fertile and inhabited by soil organisms, so that what remains is less fertile soil and poor soil quality. In order to avoid soil erosion, what can be done is to carry out reforestation or replanting of bare soil and soil that is passed by a lot of water currents, and apply terracing in order to prevent soil loss due to water flow on sloping land. D. Soil components. Rock is a naturally occurring solid material composed of a mixture of minerals, compounds, and other compositions. Based on the process of occurrence, there are three rocks, namely igneous, sedimentary, and metamorphic rocks. Rocks can come from volcanic magma. Rocks in the earth undergo weathering so that they become soil-forming materials. Air. Although the soil is a solid object, but in the soil there are cavities filled with air. The following is an example of air voids in the soil. Air voids exist between soil particles. between soil rocks, between rocks and soil particles, between soil particles and plant roots, or between plant roots and rocks. Air cavities can also be formed by the activity of soil animals, such as worms. Humus is an organic component produced from the decomposition process. Decomposition of dead animals and plants, fallen leaves, or feces by bacteria and fungi. Humus is fertile soil, because humus has a loose texture and many pores that allow air exchange. This condition causes the roots to get enough air and are able to retain water so that the soil is always moist. Humus also contains minerals and nutrients that are essential for plant growth. Here's an example of humus water. Living things that live in the soil need soil moisture. Soil moisture is caused by the presence of water in the soil. Plants also need water. Water is absorbed by plants after it penetrates the soil and reaches the roots. Minerals. Positive ions in the soil, namely potassium, K+, calcium, Ca2+, and magnesium, Mg2+. The negative ions are nitrate, number 3. Phosphate, H2PO4, and sulfate, SO42, which are nutrients for plants. The mineral content in different soils determines the nature and character of the soil. However, not all soil is suitable for cultivation. Fertile soil is determined by the mineral content in it, the physical and chemical properties of the soil. Physical properties include soil texture and structure. What is easily observed to determine soil fertility is the color of the soil. One of the chemical properties of the soil that is an indicator of soil fertility is the degree of acidity or pH of the soil. Fertile soil has a pH of around 7. At a pH of 7, plants can absorb nutrients optimally. Soil color is related to the level of soil fertility. The darker the color of the soil, the higher the organic matter content. Dark soil colors absorb heat faster than light colors, because it absorbs a lot of heat. The water content in dark soil evaporates faster so that the soil dries faster. Soil color affects the level of soil fertility. Soil color affects temperature and humidity so that it affects plant growth, activity of soil organisms, and soil structure. Organic components. Soil is a place to live for several living things ranging from bacteria, fungi, algae, insects, and earthworms. These soil organisms break down materials derived from living things to produce organic material in the soil. Currently, many farmers switch to organic farming, namely using natural, organic fertilizers instead of factory-made chemical fertilizers. The advantage of natural fertilizers is that organic fertilizers release minerals slowly through natural weathering, so that the availability of soil minerals is more maintained and there is no need to fertilize often. Chemical fertilizers provide minerals directly but are lost more quickly from the soil. Organic fertilizers and chemical fertilizers release the same minerals that plants need, but if you fertilize too often with chemical fertilizers, it will have a bad impact on the environment. Chemical fertilizers are easily dissolved and carried by rainwater into rivers, causing fertile aquatic plants. If the aquatic plants are too fertile, it will interfere with the life of the fish. When aquatic plants die, decomposing organisms need a lot of oxygen to decompose them. This condition causes the dissolved oxygen in the water to decrease, causing many fish or aquatic organisms to die. The reduced oxygen dissolved in the water is also due to the lack of sunlight that cannot penetrate the riverbed, thereby inhibiting photosynthesis of aquatic plants.